Picture a terrifying infection sweeping through a modern hospital ward. It's completely unseen, moving incredibly fast, and shutting down everything. Now imagine an ancient visionary seeing that exact same invisible threat, mapping it out centuries before the microscope was even invented. We have two massive mysteries to solve today. The first is understanding the exact mechanism that allows one single contaminated object to completely shut down a modern hospital ward. The second is discovering how a 16th century Italian poet mapped the precise spread of epidemics 300 years before anyone actually saw microbe. We are going to find clear, evidence-based answers showing exactly how a Renaissance scholar solved a distinctly modern medical mystery. To figure this out, we're traveling back to 16th century Verona to meet Girolamo Fracastoro. Born around 1478, this guy was the ultimate Renaissance mind. He wasn't just a doctor. He bridged poetry, astronomy, and medicine.
Right. He studied at the University of Padua. And what I find absolutely fascinating is his belief that poetry was the perfect way to explain complex medical science to everyday people. It wasn't just dry data for him.
You can really see his empirical brilliance when you look at his three biggest works. In 1530, he published Syphilis Sive Morbis Gallicus. Then, in 1538, he shifted gears a bit with his astronomical text, Homo Centrix. And then comes his absolute masterpiece in 1546, De Contagione. Seeing this progression really anchors his groundbreaking ideas right in the middle of the Italian Renaissance's massive scientific awakening. Let's talk about that 1530 epic poem for a second, because it has such a wild anecdote. Fracastoro wrote this incredibly vivid story about a shepherd named Syphilis. This shepherd makes a huge mistake and ends up insulting Sol Pater, the sun god. And of course, the sun god retaliates by striking him with a horrific, blistering disease. It's a genius move by Fracastoro. With one creative story, he gave a distinctly modern disease its name and simultaneously taught a massive audience about its origins and botanical treatments. He was essentially doing public health education through entertainment. That kind of outside-the-box thinking is exactly what led him to a foundational medical concept, the fomite.
Yes, and the word itself is so descriptive. It comes from the Latin word fomus, which literally means tinder. In medicine, a fomite is an inanimate object that can carry and transfer infectious agents. Fracastoro used this metaphor perfectly. He saw contaminated objects as invisible tinder, just sitting there, waiting for a spark of infection to jump to a brand new host.
You have to hear his exact phrasing from his 1546 text, De Contagione. It is hauntingly accurate. He wrote, "By foams, I mean clothes, wooden objects, and things of that sort, which though not themselves corrupted, can, nevertheless, preserve the original germs of the contagion." It honestly gives me chills. He is perfectly describing the behavior of microbes, and he's doing it centuries before anyone had even conceptualized germ theory. He took that invisible tinder idea even further with the concept of Seminaria morbi. These were the invisible seeds of contagion that he believed multiplied quickly and putrefied the body's humors.
Think of pathogens as actual, physical seeds being scattered across a population. It's a stunning piece of prophetic intuition. He couldn't see the bacteria, but he totally understood how illness multiplied through a community.
Fracastoro even mapped out exactly how these invisible seeds moved around, outlining three timeless mechanisms. The first is straightforward direct contact, like getting scabies. The second is indirect contact, which happens through those fomites we talked about, like shared clothing. And the third is transmission at a distance. Today we know this as airborne propagation. He logically laid out the entire flow of contagion between human hosts without ever looking through a lens. We also see him demanding empirical evidence over popular assumptions in completely different fields. Take a 1517 excavation in Verona, for example. At the time, the prevailing religious dogma stated that marine shells found far inland were just left there by the transient Mosaic deluge. But Fracastoro actually examined the evidence. He championed empirical science, concluding that those fossil shells belonged to living animals that actually lived and multiplied right there locally. This kind of objective observation really helped untether the scientific method from strict theological constraints. He brought that exact same rigorous boundary pushing right into his medical practice. Back then, standard medical tradition taught that astrological moon phases controlled a patient's critical days of illness.
Fracastoro completely threw that out. He insisted that the physical, qualitative alterations of the illness itself are what dictate the critical days. He chose to rely entirely on observable clinical phenomena, completely bypassing astrology.
That strict dedication to empirical data created a massive 300-year ripple effect across the scientific world.
Absolutely. His theory of those seeds of disease survived as a foundational intellectual concept. It eventually inspired the 19th century bacteriologists. Fracastoro essentially laid the groundwork for modern epidemiology and the verifiable germ theory we depend on today.
Bringing that 16th century insight straight into our lives today, we have to look at modern fomites. Think about stethoscopes, doctors' neckties, gym weights, and especially our daily touchscreens. These are today's dangerous tinder. Everyday objects in our routines can easily form biofilms and harbor serious, stubborn pathogens like MRSA or hepatitis B. This brings us right back to our opening mystery about the hospital ward. When you look at viral survival times on different materials, the difference is stark. Porous materials, like paper or cotton, actually trap contagions, breaking them down in minutes or hours.
But non-porous materials like smooth stainless steel bed rails or plastics allow viruses to survive for days, sometimes weeks. This perfectly explains the exact mechanism of how pathogens transfer so efficiently in a fast-paced clinical setting.
Armed with this knowledge, we have 3 practical, actionable points for curious professionals. Point 1. You must identify and relentlessly disinfect high-risk, non-porous fomites.
Point 2. Always separate empirical data from dogma. Trust pure observation over comfortable assumptions.
And point 3. Communicate science creatively. Find vivid, relatable narratives to educate the public, exactly like Fracastoro did with his poetry. Looking back at Fracastoro's absolute brilliance leaves us with a provocative realization. It is highly likely there are invisible threats we are still completely overlooking today, just waiting for the next visionary to bring them to light. Thank you for joining us for this explainer. Disclaimer and bibliography in the description.